We're going to use a technique of integration called the method of partial fraction to integrate x squared minus 4 over x cubed minus 3x squared minus x plus 3. Now you could attempt a u substitution by letting u be the denominator, that is x cubed minus 3x squared minus x plus 3. Then du is going to be 3x squared minus 6x minus 1 dx. And you can see in order for this to work, the numerator x squared minus 4 has to be a multiple of 3x squared minus 6x minus 1. So we have to multiply it by a constant, one of them, to get the other. That's not possible. So u substitution will not work. The only method that is going to work is called the method of partial fractions. And what that method does is break down our rational function into simpler functions, and then we'll be able to integrate those simpler functions easier. First, we have to make sure that the degree of the numerator is strictly less than the degree of the denominator. In our case, the degree of the numerator is 2, clearly strictly less than the degree of the denominator, which is 3, and we can proceed. If that was not the case, we would have to use long division first. So the key here is the polynomial in the denominator, x cubed minus 3x squared minus x plus 3. It's a third degree polynomial, and any third degree polynomial can always be expressed as a product of a linear term and an irreducible quadratic term, or a product of 3 linear terms. We're going to show you how to do it, break this polynomial down in 2 different ways. First, we're going to combine the first and the third term and the second and the fourth term. So let's rewrite it: x cubed minus x minus 3x squared plus 3. These 2 terms have an x in common, and these 2 terms have a minus 3 in common. So let's rewrite it: factor out x. That leaves x squared minus 1. Factor out minus 3 in the last 2 terms, which is going to leave x squared minus 1 as well. Now factor out x squared minus 1 times x minus 3. And this is x minus 1 times x plus 1 times x minus 3. So this polynomial is a product of 3 distinct linear terms. Another way to see it is by inspection. See that x equals 1 is a root. That's because when we plug in 1 for x, we get 1 minus 3 minus 1 plus 3. That's 0. So x minus 1 is a factor of our polynomial x cubed minus 3x squared minus x plus 3. That is, if I take the polynomial x cubed minus 3x squared minus x plus 3 divided by x minus 1, it's going to leave no remainder, 0 remainder. We can either use long division or synthetic division. I'll use long division. So x cubed minus 3x squared minus x plus 3 divided by x minus 1. We're going to put an x squared here. So x squared times x is x cubed minus x squared. Now subtract. This gives us minus 2x squared minus x plus 3 minus 2x minus 2x squared plus 2x. Again, subtract. The x squares cancel, and we have minus x minus 2x. That's minus 3x. So this is minus 3x plus 3, and all we're going to need is minus 3. So minus 3, that's negative 3x plus 3, and then subtract. We see the remainder is 0. Therefore, this polynomial x cubed minus 3x squared minus x plus 3 is equal to x minus 1 times x squared minus 2x minus 3, and the quadratic polynomial factors into x plus 1 times x minus 3. And that's how we break down the polynomial in the denominator. Let's return to our integral. We wanted to integrate x squared minus 4 over x cubed minus 3x squared minus x plus 3. It's now the same as the integral of x squared minus 4 divided by x minus 1 times x plus 1 times x minus 3. So we'll use partial fraction decomposition to break down this irrational function. X squared minus 4 divided by x minus 1 times x plus 1 times x minus 3 can be expressed as a constant a over x minus 1 plus another constant b over x plus 1 plus another constant c over x minus 3. Now let's find a, b, and c, and the problem will be much easier. So first we'll take x squared minus 4 divided by x minus 1 times x plus 1 times x minus 3 and multiplied by x minus 1 times x plus 1 times x minus 3. So you can see these all cancel. We have to do the same thing on the right. A over x minus 1 times x minus 1 times x plus 1 times x minus 3 will cancel x minus 1s. Plus b divided by x plus 1 times x minus 1 times x plus 1 times x minus 3 is going to cancel x plus 1s. Plus c divided by x minus 3, x minus 1, x plus 1, x minus 3 is going to cancel x minus 3. So let's see what's left. We have x squared minus 4 on the left, a times x plus 1 times x minus 3 plus b times x minus 1 times x minus 3 plus c times x minus 1 times x plus 1. To find a, b, and c, we're going to pick constants that make some of the stuff on the right 0. So x equals 1, x equals minus 1, and x equal to 3. When x equals 1, the left-hand side is 1 minus 4, which is minus 3. The b and the c parts are 0 because of x minus 1. And we just have a times 1 plus 1, that's 2. 1 minus 3 is minus 2. So minus 3 equals to minus 4a. Therefore, a must be 3 divided by 4. Plugging in minus 1, we still have minus 3 on the left. We have the a and the c terms are gone because of x plus 1. And that's equal to b times minus 1 minus 1, that's minus 2. Minus 1 minus 3 is minus 4. Minus 3 equals 8b. b must be minus 3 divided by 8. Plugging in 3, 9 minus 4, that's 5. The a and the b are gone because of x minus 3. C times 3 minus 1, that's 2. 3 plus 1, that's 4. So 5 equals 8c. And c is equal to 5 divided by 8. Our integral, the original integral, was x squared minus 4 divided by x cubed minus 3x squared minus x plus 3. After factoring, that's x squared minus 4, x minus 1, x plus 1, x minus 3, and that was equal to the integral of a over x minus 1, b over x plus 1, c over x minus 3. So we know a, this is 3/4 times the integral of 1 divided by x minus 1 minus 3 over 8 times the integral of 1 divided by x plus 1 plus 5 divided by 8, the integral of 1 divided by x minus 3. And all these are extremely easy integrals. So we end up with 3 divided by 4 ln absolute value of x minus 1 minus 3 divided by 8 natural log absolute value of x plus 1 plus 5 divided by 8 natural log absolute value of x minus 3. If we want to leave the answer as 1 natural log, we would have to multiply this by 1/8 times 8. That's just a form of 1 times 3 over 4 ln absolute value x minus 1 minus 3 over 8 ln absolute value x plus 1 plus 5 over 8 ln absolute value of x minus 3. Send in 8, keep the 1/8 in front. So this is 1/8 times 6 natural log of absolute value x minus 1 minus 3 natural log absolute value of x plus 1 plus 5 natural log of absolute value of x minus 3. And the final answer looks like this. 1/8 natural log of absolute value. In the numerator we have x minus 1 to the 6th times x minus 3 to the 5th. In the denominator we have x plus 1 cubed. And you can add a constant of integration at the end. We also can call it c, so we're not going to confuse this c with the c that we had earlier, which was a constant. So that's the final answer after applying the method